Okay, example 1. Use the calculator. Oh, bust out your calculator. To find the value of each expression, round to 2 decimal places. I'm going to test it out. Why don't you punch all in, A, B, and C, and write the answer in your notes. It's okay to be wrong. And then I want to confirm to see if... How do you switch to degree mode? We want in radians. Very good. Okay. Please switch to radians. Only radians. Radians. Hit mode. Everyone hit mode. Hit mode. Thank you for bringing that up. Hit mode. And then go to radians. Hit mode. Everyone find mode. Make sure it's radians highlighted. Okay? All right, try it. A, B, and C. I want to see if you can use your calculator. If not, that's okay. Do you know what the button sign inverse is? Once you have a calculated answer for A, can you kind of compare first before you write it in your notes? If all 3 or 4 of you or both of you have matching calculated answers, then you are okay. So punch in each one, then compare each one. Are there buttons already for sine inverse, cosine inverse, and tangent inverse? Okay. So make sure it's in radians, okay? All right, here we go. Carlos. Solution for A. Negative 0.13. Is Carlos correct? Yes. So here's my question. Is then the next one 1 divided by 8? No? Okay. Noelle, what did you get for B, dear? 1.45. 1.45. Is that okay? Yes. Next one. Emma. That's okay. I'm not in no rush. I can wait. 0.33. Someone confirm? Yeah. Perfect. So that's how you use a calculator for sine, cosine, and tangent inverse. We'll deal with the other ones that's not in calculator later. Example 2. Find the exact value. Calc or non-calc? Non. All right. Sine inverse of 1. So let's first talk about restriction, because you can't have an inverse without knowing its restriction. This is when the quadrants will come in. What 2 quadrants can sine inverse be in? 1 and 4. That's why we're using quads. Okay. It can only be 1. There's a guy right here. Okay. If you want to pass that, he's going to ask you for your passport. And then negative pi over 2. So you can't go beyond those 2 quadrants. Okay. Sine inverse of 1 is exactly what radians? Pi over 2. And the whole radians, all answers should be in radians. We're going away from degrees. We got to think in radians. All right, I'm going to write pi over 2. I'm going to ask you, do you agree? If you disagree, let me know. All right, next. Sine inverse of 1 over 2. What quadrant, and only one quadrant, can this answer be in? 1, right? Somewhere in 1. Would you guys agree? What radians? Pi over 6. You are correct. How do you know that the answer is in quad 1? Because it's positive. That's why we restrict each inverse function to a positive quadrant and a negative quadrant. Cosine inverse. Let's talk about restriction. What 2 quadrants can cosine inverse be in? 1 and 2. So this one I can go all the way out to pi. Okay, so there's a guy over here now. He's like, show me your passport. Okay. Question number 2. Now we've determined the quadrants. What is the only quadrant that cosine inverse of a negative rad 2 over 2 be in? The second quadrant. The second. Okay, because that's a quadrant that will give me a negative ratio for cosine. Now, what is it, Daniel? Daniel said it's 3 pi over 4. Do you guys agree with Daniel? Yeah, okay. Okay, you and your team, try out D, E, and F. I'm going to put 3 minutes. Hey, try one, compare answer. Try second, compare answer. So that way you're not so off. And if you work with tangent, maybe draw the quadrant so you know.
Because it would be 30 and 30 yeah, because it over 3 then one would just be 45. Yes, 5 over 4, right? What is it? Yeah, 5 over 4. I was trying to think of it, but now it's either 0 or 1. I know that. Yeah, we both think that's what geometry works for. Just like we did everything. Oh yeah. So we'd say so like we're saying yeah, us both. We were both communicating together.
No, that's not.
We can exact same way. Yeah, we both understood each other in geometry, so I don't know, it just like came up because like since yesterday we did like this. Yeah, it's refreshing. Yeah, it's like oh, it comes back to B. Same thing like Mr. Gross. Pi or 0, we're able to like cosine 0. Oh, whoops. I love this. I don't remember it's pi over 2, but I know 1 and 4. So yeah, because cosine there's just elimination. Yeah, like I know it's pi over 6. I go 1 over 2, 6.
Multiples of pi over 4 is
I worked that out.
All right, here we go. D. Ready?
Yeah.
D. What did you guys get?
Pi
over 2. Okay. Cosine inverse is restricted again over here. Okay, it's 0. So these are usually these are the ones that's either 1 or 0. Okay, so this one's going to be pi over 2 for cosine. All right. Tangent inverse. This is our first tangent inverse problem. Yep. Quadrants?
1 and 4.
1 and 4. Okay. It has to belong in what quadrant? 1. By the way, technically, can I write this as tangent inverse if I want to write it like that? If some of you can see that easier? So if I were to draw a triangle, tangent is going to be opposite over adjacent, right? What angle has an opposite leg of 1? We've been using it a lot lately. 30 or pi over 6. Okay. So that's a pi over 6. And last one. What quadrant should the answer come from? 1. What angle? I love these. Pi over 4. Yeah, because tangent of pi over 4 or multiple of pi over 4 will give me 1 or negative 1. All right. Refresh. Those are just like singles. Daniel.
What was your logic behind E again?
I'm sorry, behind what?
E, like the triangle.
Because all 30, 60, 90. Okay, so remember we have been using a lot of 30, 60, 90, Daniel?
Yeah.
Okay, so here's 90, here's 60, and here's 30. Remember all of these right here that we've been using? So remember we said, hey, let these all be 2's? Right, and this was 1 then? And we said that was rad 3? Okay, the ratio, Daniel, of all 30, 60's is always that. Okay, so when I rotate them, doesn't matter. Even when I put them in here as a 60 degrees, Daniel, here's 60, that means that opposite will get rad 3. And this one will get 2 still, and this will get 1. Okay? Yeah, so in trig, there's only 30, 60, 90, or 45, 45, 90. And then the quadrant is 1, obviously. Okay. All right. Here we go. Find the exact value of each. Cell means undefined if it doesn't work. How do you know? Okay, first we're going to decide inside. Remember, when we're doing this, we have to do the parentheses first, right? Sine of pi over 8. Do we have any restriction? No, it's a normal function. If it's a normal function, it can be anywhere it wants to be. But, okay, then let's say, and the reason I want to do this out is because when it gets to a little bit more difficult, you want to understand this. So here's an angle, it's pi over 8. Would you agree that sine is some value of y over some radius, which is unknown? Okay, and I don't care because I don't have a calculator, but I just want to find the end result. So now you have sine inverse of some unknown y divided by some unknown radius. Is that true so far? I know it has to be in quad 1. That's all I know. Any questions so far? Then I now have to go do sine inverse, which is now restricted to what two quads? 1 and 4. But this angle is already in quad 1. So that's why I know whatever it is, it has to be pi over 8. Okay? That's one way to think of it. And if you have your way already, go for it. I'm just reviewing this stuff. You already, last year, you did this already, right? Okay, so if you have a system that you like, use it. Hey, cosine inverse first in the parentheses. Right away, restriction or none? Restricted, because it's the inverse. It can only be where? 1 and 2. Okay? Now, I'm going to write this out. Y equals cosine inverse of x. Is that okay to kind of mimic this piece? Yesterday, we defined the domain and range for all of the inverse function. Okay. Again, yesterday, we defined the domain and range for all of the inverse function. This is when it's going to come into play. What is the domain of our inverse function? Yesterday, we defined them all. What is the domain of our inverse function? -1 to 1. Okay, this is where it's going to be important. Can you see that x is the domain of this inverse? Right? Domain is -1 to 1. In here, it says 0.2. Can you see all that's related? So it's 0.2, which is x. Is it in the domain? Yes, that means you can have an answer. If it's outside of the domain, will you have an answer ever? No. So I'm going to have an answer. And because it is within the domain, remember in trig we said these two can technically do what? Cancel. Okay? Only if it's within the domain. Because it's in the domain, it's now cancel. So now you just have 0.2. Again, if it's only in the domain. Okay? That pink is really dark. Okay, questions so far on A and B? C, D, and E, and F, okay? All right, why don't you try C for me? So in your team, I'll put 2 minutes on the clock for you guys to talk about C. Actually, a minute, because it's not that hard. So C, just work out C. D is a little bit more difficult, so just do C. Once you have an answer, can you share it in your team?
Yeah, I was gonna say
Okay, so raise your hand if you give me the answer to C. 5 pi over 6, you said. Do you agree with him? Okay, so let me ask you this question. Is the answer to D 7 pi over 5? Why not? It looks similar. Okay, so let's talk about C because that's going to relate to D. C, the inverse function is restricted to 1 and 2. 5 pi over 6, by the way, what quadrant is that in? Second. Is that still within the restriction of inverse? Yes. So can I cancel those? Perfect. So that's how we come up with that. Now 7 pi over 5. Can you tell me the restriction for tangent inverse, please? 1 or 4. Now 7 pi over 5. Tell me the quadrant. How far am I going? So this is pi, so that's 5 over 5. Okay, but right there. It's 7 pi over 5. Someone tell me this reference angle, please. What's the reference angle? 2 pi over 5. Okay, important. We have to remember reference angle. Reference angle's got to be less than 90 degrees or less than pi over 2. It always has to be positive. So this is 2 pi over 5. I'm going to hold on tight before I go any further. Can you see that or no? Well, I'm in quad 3, or 7 pi over 5 is actually not me. 7 pi over 5 is in quad 3. It does not belong in the restriction of tangent inverse. You need to bring it back. Bring it back to which quadrant? 1. Why 1? Right. Tangent of 7 pi over 5. I don't have an exact answer, but I just know it's positive. Because I think Kira told me earlier, all students take calculus, right? Because tangent in quad 3 is positive. There is another positive answer for tangent, and it is in quad 1. Well, tangent of 7 pi over 5 is identical to tangent of what in quad 1? 2 pi over 5. That's why we need to find the reference angle. Okay? So, now I can bring it back. Tangent inverse of 7 pi over 5. I'm not using that anymore. I'm going to use 2 pi over 5. Now, it's 2 pi over 5 in my restriction. Whoa, I can cancel. So guess what? I'm going to end up with 2 pi over 5. All right, I'm going to hold on tight so you can ask me questions. Yes? Okay, good question. How did we come up with 2 pi over 5 in the reference angle? What's your tool? How do we get it?
use 180 and then you subtract 7 pi over 5.
Yeah, so can you see the original angle is 7 pi over 5? Half a circle is how big? Right, so that's why I wrote like a pi right here. So pi with denominator 5 is really 5 over 5. That's right. So with denominator 5 is really 5 pi over 5. But then I need to go all the way to 7. So that's how we get the extra 2 pi over 5.
So like say the problem was in the second quadrant, would you do the same thing but reference it to the quadrant? Correct. Good question. Do you guys hear what you said? What if I give you this? Like, make up one. Different color. Here we go. Tangent inverse of, let's say, 4 pi over 5. I'm sorry, no, of tangent 4 pi over 5. Tangent of 4 pi over 5. Can you see that 4 pi over 5 is in what quadrant? It's second, right? Which still is not in the restriction. But what is this reference angle? 1 pi over 5. Okay, so pi over 5. Well, I'm in quad 2. Is that positive or negative for that answer? Negative. So tangent of 4 pi over 5 is negative.
I'm going to hold on tight for right now. So you need to bring it back. So tangent of 4 pi over 5 is negative, which is equal to tangent of what? Negative pi over 5. And you have to use negative pi over 5 because, pi over 5. Because I'm going clockwise now. Is that clear? I can't go, guys, you can't go this way anymore. Whoa, right? Because you're passing this guy, this guard. Okay, so to get to quad 4 for tangent inverse, you can't go that way anymore. Because there's a guy at the very top at pi over 2 is going to ask you for your passport, and you are not allowed to go that way. Okay? You have to go this way, which is now a negative pi over 5. So can you see that tangent of 4 pi over 5 is now equivalent to tangent of negative pi over 5? So rewrite that to make it fit in the restriction. Is that clear? And then, because now it fits, what? So final answer is? Right. Sorry, that's negative. Okay? Okay. Last two. On this example, why don't you guys, no calculator, discuss the answers. All right, Alyssa, what's your final answer? Not defined. Thank you. Not defined. Hey, you know, do me a favor. Can you punch that in your calculator? What did the calculator say? What did it say? Domain error. Domain error. Your calculator must be broken. No, because it says domain, right? It's not in the domain. Domain error means this is not in the domain. Okay, so how about F? Same thing, right? Because the domain is, again, it's still from -1 to +1. Okay? Okay, I'm going to stop right here. Why don't you take out your packet and complete odd questions?